So now we're going to add and subtract radicals. All we did yesterday, day before, was simplify them. Go from an entire to mixed, a mixed to an entire. Add, subtract. Remember with fractions, you would much rather multiply and divide them than add them, right? Why? Because when we multiply and divide, we don't need a common denominator. Okay? We're not talking common denominators here yet, but adding and subtracting, I've found, is still a little trickier than multiplying and dividing. Let's look at this. What does that say? Square root of 2. Let's say it in big kid language. Root 2. Root 2 plus 5 times root 2. We don't have to write the times in there. Root 2 plus 5 root 2 is 6 root 2. You think that works? Is that true or is it false? Well, it's saying, pull out a calculator, let's figure it out. Root 2 plus 5 root, not 29, root 2 is 8.48 something something, goes on forever and ever and ever, because that's an irrational number. Any square root that's not a perfect square is going to be an irrational number. And let's see if that's equal to my answer. 6, well, I don't want to do that. I want to go 6 times root 2. On this calculator, we don't have to put the times in there. It does bed mess. Now, do we think that's the same thing? Yeah, we've proven it. Okay? So I can do this. Why do you think I can do this? It's the same. Okay, what's the same? Do we know yet? Because a couple of things have to be the same. Let me make a substitution. I'm going to say root 2 is x. Okay? So I have root 2 is x, and 5 root 2 is x is 6 root 2 is x. Does that work? Yeah. X and 5x is 6x. Okay? Is that helpful? Sure. Let's go on to 2. Let's make a substitution. Cubed root of 5. Come on, pen. What's your favorite letter, Dan? Come on, you got 26 choices. Pick one. Z. All right. I'm going to let cubed root of 5 be equal to z. Okay? So for 2, I have 4z minus 7z. Make sure you put a line in there. It looks like a 2. Equals negative 3z. Do we think that works? It does. Okay? Now you substitute back in. Let's put that back in. Well, hey, you can try it on your calculator, but I'd rather save the 6 seconds. That works. And again, that worked. How about this guy? Let's let root 8 be what, Loyal? Pick a letter. X. I already used X. Come on. Okay, Y. Why not? So 5y minus 2y plus 7y. What do you think this answer is? 5 take away 2 is 3 plus 7. Hey, that's 10y. That also works. So we can add or subtract radicals. How about this one? What do you think is going to happen here? Can I do that? 7 and 7 is 14. Is that going to work? Well, I'm not sure. Let me try. Yep. I hear a yep. Okay, I hear a no. 7. That's cubed root of 5. and that is 27.6. Is that the same as, whoop, the fifth, oh geez, come on. All right, let's try that again. 14 times 5, hit wrong button, the fifth root of 5. That's definitely not the same as 27.6. So this doesn't work. Now who wants to go out on a limb and say why it doesn't work? Reese. They are two different roots. Well, what do you mean root? The 5's different? Okay, one's a cubed, one's a square. Correct. What do we call that 3 or that 2? Anyone remember? Yeah, I skipped over it the other day and said you don't need to know this. Well, it would be helpful to know what it's called. That's called the index. We have a different index, so we can't add these. Is this the same index? Yeah, they're all cubed roots. Do we think we can add these? All right, let's have a look. I'm going to go cubed root of 3 plus cubed root of 2, and that is 2.7. That should be the cubed root of 5. Right? Wrong. What else isn't the same here? Radicand. Wow, what a cool word that is. Did I say you had to know it? Okay. That number is not the same. Let's skip down to what it says here, okay? Because this is, you know, in the old days, this is where we'd start. There's the rule. You can add or subtract radicals if they have the same radicand and index. Well, so can I add those? There's the index. There's the radicand. Are they the same on both? Yes. Okay. So, but something like this, can I add those? Same index. Do I have the same radicand? That's the number under the root sign in layman's terms, right? No, I can't add those. Can I add these? No, same radicand, different index. Cannot do, okay? So that you just have to stick in your noodle, okay? You got to remember it. Okay, so I'm not going to verify that these work. Okay, it tells us they do. Let's just skip down and get some concrete examples. Knowing our new rule. Write each expression in terms of a single radical. This is where we first teach you how to simplify these things. Now we're going to throw a couple of them and add them together, if we can. So, does it say simplify it? It doesn't necessarily say that. Like, maybe you see, I could make this root 20s. Okay, that's 4. Does that pen show up okay? Jake? Okay. Well, 80 is 4 times 20. And I know I can take the square root of 4 Okay, that's a times, not a minus. Okay, which is 2 root 20, jeez, minus 1 root 20. It's how many root 20s? Yeah. Make a substitution. Root 20 is x. I have 2x minus 1x is 1x. But I don't need to put the 1 there. Okay? Technically, it doesn't say completely simplify it, but you know what? We should. Because just because that one works doesn't mean, you know, we can get root 80s out of this. You're probably better off to completely simplify it first. So this one, I know I can still take a perfect square out of 20, right? Two, take away 1. Right? Let root 20 be x. 2x minus 1x is 1x. Because that is root 4 times root 5, otherwise known as 2 root 5. Okay? Okay? Cubed roots. What's our cubed table? 1 times 1 times 1 is 1. So the cubed root of 1 is 1. 2 times 2 times 2 is? So the cubed root of 8 is 2. 3 times 3 times 3 is 27. So the cubed root of 27 is 3, and so on and so on and so on. Okay? Which one of these can we take out of 80? 8. Nice, nice. I want to split this up into an 8. Okay? Because I can take the cubed root of 8, that's 2. 270. Which one of these goes in 270? Am I going to have a root 10 in here? Well, that would be handy, wouldn't it? Let's find out. This is the same as cubed root of 8 times the cubed root of 10. This is the same as the cubed root of 27 times the cubed root of 10. And this cubed root of 8 is, again, 2. This pen is not being very nice. So that's 2 times cubed root of 10, or 2 cubed root of 10s. And this is 3 cubed root of 10s. Dannon, what's your favorite letter? J. J's jalopy. I have 2 J's and 3 J's. If you have 2 old jalopies and 3 old jalopies, Dannon, how many old jalopies do you have? About 5. Now what's J stand for again? Cubed root of 10. Okay? What could be funner, guys? Writing English essays? Yuck. Okay, I kind of wrote all over where C's got to go, so all right. Look at this nice one. Don't freak out. Guys, let's focus. This isn't easy. One at a time. Okay, break it down into small parts. Don't look at any of this. Pretend that was a question you got yesterday, the first thing. Simplify. Okay? How do I simplify this? I don't want root 108. I want probably the smallest root I can find. Odds are the rest of them will be in the same terms as that one. What perfect square is in 108? What's the first one you want to try? Oh, 4 goes in there. Then I have root 27s. Can I take the square root of anything in 27? Because we don't have a heck of a lot of space here. So I want to come to the conclusion that there's a larger perfect square than 4 in there. Okay? What else perfect square goes in 27? 9. What's 9 times 4? So that must mean 36 goes into 108. 108 is 36 times 3. Minus 5. I get some. Jeez. I need to ground my pen on something metal, and then I won't have as much static. So let me try this. Then again, could be the battery in the pen. All right, I'll ground myself. Now, let's try again. It's not going very good. Hey, let me try a fatter pen. No, likes that better. Okay. 108 was what? 36 times 3. Okay? Are we all happy? Is that the same thing? I haven't changed it at all. But see, like I'm saying, I got lots to do here. We're going to have to start getting a little bit quicker with this. I can take a 4 out, but then I will see I can also take another 9 out. Okay? So let's just do it all at once. If you don't follow that, we'll all get the same answer. You'll just use a little more pencil and paper. Okay? So what is this? That's root 36 times root 3. And what's root 36? 6. 6 times negative 5 is negative 30 root 3. I think the first one's done. What can I do with the second one? Is there a perfect square in 8? There is. So I can go, I still have 3/4. That's supposed to be a 3. Okay, that's root 4 times root 2. All right. So that's 3/4. What's the square root of 4? Times 2 times root 2. And what's 3/4 times 2? 3/4 times 2 is 3/2, otherwise known as 1.5, but let's just leave it as 3/2. Okay? Everyone see that? So I have 1.5 root 2's. Can I add root 3's and root 2's? No, that's a different radicand. But that's what I got. Okay? Don't assume you can add all 4 of these guys and collect into one thing. It looks like I got 2 different things going on here. Negative 5/4 root 48. What's a perfect square in 48? Does 4 go in there? Yeah. But is there another perfect square in 12? Therefore, Yeah, what's 4 times 4? 48 is 16 times 3. Remember prime factorization in grade 10? This is why we taught this to you. Okay? Break down 48 into its prime factors. You can see how you can get the largest perfect square. 48 is 4 times 4 times 3, or 16 times 3. So I'm going to break that up into root 16 times root 3. Okay? If you just take a 4 out, don't worry, you should get the same answer, but then you're going to have to take another 4 out. Okay? And I got 5/4. What's the square root of 16? What's 5/4 times 4? Yeah, what's 4 divided by 4? It's gone. That's -5 root 3. Everybody okay with that? Three down, 1 to go. 1/2 root 50. Do I want to go 5 times 10? That doesn't help me. I don't know the square root of 10. I don't know the square root of 5. But I can go 50 is 25 times 2. And I do know the square root of 25. What's 1/2 times 5 as a fraction? 5/2. Everybody loves fractions. Okay. What a lovely question. I'm not done, because I can collect some of these radicals together. How many root 2's do I have? Well, I have, careful, I have 1.5 root 2's. I have 2.5 root 2's. If you like decimals, you're going to say that to yourself. How many is that? What's 1.5 and 2.5? 4. Or I have 3/2 root 2's and 5/2 root 2's. And how many is that? I have the same denominator, so I can just add straight across. What's 8/2? 4. Same thing, right? Okay, so this thing gives me 4 root 2's. What else can I collect? Root 3's. Oh, no fractions, thank you. Minus 30 root 3's, minus 5 root 3's. How many root 3's do I have? What's minus 30 minus 5? Minus 35 root 3's. Can I collect root 2's and root 3's, Tanner? That's right, no. I'm recording you right now, right? Because they have a different what? Shannon? What? What? A different radicand. I can't collect them. Do they have the same index, Will? Yes, they're both square roots. That's square root 2, square root 3, but I can't collect these. That's as far simplified as I can get this, okay? Can't do anything else. All right? Well, that was fun. Does this one look nastier? I'm not sure. What's the cubed root of 64? That wasn't too bad. Okay, cubed root of 375. Where's my cubed root table? Is there anything stopping you from writing your own cubed root table every time you do a question? Where is it? Oh, right there. What's 5 squared? Oh, sorry, 5 cubed, excuse me. 125, huh? Do we see a 125 in 375? Ooh, is 125 times 3 375? 125 times 3 is 375. You know what, let's just finish these two first. 4/8 is also known as 1/2. What's the cubed root of 125? 5. Okay. Let's go on to the next one. That says 2/3. Okay? That's a number. I want to take that out front. Now all that's multiplied by is the cubed root of 54. What is a cubed root that goes in 54? 27 goes in there how many times? Cubed root of 27 times the cubed root of 2 is the cubed root of 54. Have I changed it at all? No, I just converted it, broke it down into something I know what to take the cubed root of. Okay, so that's minus 2/3 times, what is the cubed root of 27? 3. I'll use a bracket this time. Oh, that's nice. That's just going to be 2. That's a 27, sorry. It's my pen's doing strange things. Okay, last one. What's the fraction there? 5/2. Otherwise known as 2.5. Cubed root of 24. What is the perfect cube in 24? 8 goes in there 3 times. Oh. Did I forget something? Yeah. This is a cubed root. I'm sorry. That's not square root. I was just looking to see how many cubed roots I could collect. Okay, so 5/2. The cubed root of 8 is 2. And I have cubed root of 3. All right. One more line, maybe 2. Have a half. What's 2 times 5? I got 10 cubed root of 3's. Okay. What's 2/3 times 3? Yeah, 3's cancel out, or if you want to do it the old way, that's 6/3, which is 2. Same thing. That's minus 2 cubed root of 2's. And what's 5 times 2 divided by 2? 5 cubed root of 3's. Anything I can collect down here? Do I have like terms? You remember exponents? You can add x's together, but you can't add them to x squareds. You can't add them to x cubes, right? These are all unlike terms. Same thing with these. I have a couple of like terms. What are they? Cubed root of 3's. Okay? I have 10 of them here. I take away 5 of them. How many cubed root of 3's do I have left? Yeah. But let's put our number out front. 1/2 plus 5 cubed root of 3's. This is the only root 2's I have. I have minus 2 cubed root of 2's. And, well, what else can I do? Can I simplify anything else? No. These are all unlike terms. That's my only number. That's my only cubed root of 3's. That's my only cubed root of 2's. That's the final answer. Okay? Welcome to Math 11 Pre-Calculus. One little more one to do, and then you're on your own. Okay? What am I trying to find here? I know you want to try to get an area of some kind because you see a closed shape. Is it asking you for an area? Length, one dimension. Okay? I want the length of x. That's this piece right here. And as an exact value, that means don't put that simplified radical in your calculator. And then, now do put it in your calculator. Okay? If you don't see the strategy here, there's no way you're going to be able to get this question. There's a way to solve this. What do I need to do to solve for x? Don't yell it out. Let me just do one little thing. I'm going to call this, all this junk, A. I'm going to call all this junk B. What do I need to do to solve for the length of x? Reese? Subtract B from A. B is this length. A is this length. Do we see how this length, take away this length, I'm left with x? Okay. This length, let me rewrite where B is. B, this length right here, is the same length as here, right? So B plus x equals A, right? B plus x, that's the length of A. So to get x, we need to subtract B from A, we're left with x. That's visualization. It's hard to teach if you don't see that, okay? Let's get rid of all that. All right, x is A minus B. That's what x is. Okay? Who's not clear with that still? Anybody? Let's go back to, let's say grade 8. What's x here, Tanner? Okay, you just did exactly what I just did right here. This is 2. That's the same length as here. We have to assume there's right angles here, otherwise there's no way we can come up with this answer. If this is 2, 2 plus x equals 8. What must x be? Well, it's got to be 6. Okay? This is exactly the same question, only it's not 2, it's 5 root 27 minus 4 root 18. Okay? That's all I can say. All right? Did I forget something here? All of this is subtracted from A. All of it. If you don't put brackets here, you made a mistake, okay? That whole thing, B, is subtracted from A. You have to have brackets. If you like, put them here too, but those brackets aren't going to do anything because this sign out front is positive, okay? We don't need those ones, but you have to have them here because you know this minus is going to change this sign here to positive, right? So that's the first thing we're going to do. Nothing else but change that to a positive. Plus. So minus 5 root 27 minus times a minus positive 4 root 18. Okay? If that's a 2-mark question, guys, and you have that, you have at least half out of 2. If I'm generous, maybe even 1 out of 2. 50%. Okay? That's the concept. The rest is just the skill. What we've been doing the last couple of days. Can we simplify this thing? Okay? 8 root 2's. Can I make that any smaller? Or is that fully simplified? Yeah. I don't know. There's no other perfect squares in 2. Is there a perfect square in 12? Yeah. I can take 4 out. Okay. So I have 8 root 2 plus 2 times root 4 times root 3, that's root 12, right? Is there a perfect square in 27? Yep, it's 9. Whoops, forgot my 5. And how about root 18? I can take a 9 out. Root 9. Okay? Yep. This is called distributive law. If you have this in grade 9, and all it said was expand or multiply, right? Everything outside the brackets is multiplied by everything in the brackets. So that minus 2 times 2, that becomes a minus 4. That, you know what, let's make that a minus just so it's consistent. So that minus 2 times minus x becomes minus times minus plus 2x, right? Same thing. This, if you like, that's the same thing. It's minus 1. We just don't need to write the 1. Okay? Okay, square root of 4 is 2. 2 times 2 is 4. I'm going to skip a line, okay, because I'm running out of room. Square root of 9 is 3. 3 times negative 5, negative 15. Use this thing. Minus 15 root 3's. And square root of 9 is 3 times 4, 12 root 2's. Can I collect anything here? Can I add or subtract radicals because they have the same index and radicand? Yep. Root 2's, I got 8 of them. And I have 12 root 2's. How many root 2's is that? 20 root 2's. All right. Root 3's. I have 4 root 3's minus 15 root 3. How many root 3 is that? Minus 11 root 3. That's A. That's an exact answer. Do you know how to put that in your calculator and get a decimal? To the nearest tenth. If you got a good one, you don't have to worry about bed mass. You just plug it in. And if you got a bad one, none of you guys have a bad one. Answer the question, how many decimals do I want? To the nearest tenth, that's 1 decimal. That's 9.2. Okay. Number. Jesus. 1 to 3 odds. Four and 6A. Okay, no quiz announced yet. Won't be tomorrow, but it might be Wednesday or Thursday. Okay, just looking ahead. Don't fall behind, guys. I'm here at lunch.